Okay, so let's do it. Welcome back from lunch, and I hope you had a good lunch. I had a good one, although it was a little bit short thanks to... Sorry, man.
I apologize.
Okay, so this afternoon we'll start with what I like to call a war story. So basically a story how we built MyGet, which is a software as a service solution. I'll talk a little bit about it, what it does, so you can have an idea about the workloads we are seeing. And we'll just go from, well, basically the beginning, the first lines of code we wrote, to what the solution is we currently have online, both on the software level and on the infrastructure level on Windows Azure, how we did certain things and so on. You will see several things that I'm noting that we actually found working in our situation. As with everything, take this small precaution. Not everything I'm telling here will work in your solution. So I'm just giving our story, think about it, and try to incorporate the things that you think may work in your solution, but just don't go blindly copy it, because it may fail in other scenarios. I'm Martin Mayo. You can find my Twitter handle, and I try to tweet less nowadays, but I'm Martin Mayo, and I have a day job, which is working as a technical evangelist for JetBrains. So if you have questions on ReSharper, PHP Storm, TeamCity, things like that, ping me during day, because during night I am the co-founder of MyGet, which is the thing I will be talking about today. I'm also writing version 2 of our Pro NuGet book, so if you buy this one, you can buy the next one in November, which is always better, because 2 books is better than 1 on my bank account. I'm also co-founder of the Azure user group in Belgium, so the AZUG. By the way, if you're interested in beers and want to fly over to Belgium, go to cloudbrew.be. The registration is not live yet, but we're planning a conference at a brewery, so it might be interesting. My focus is on everything web-related, so ASP.NET MVC, ASP.NET web forms, although I try to avoid that, Web API, Windows Azure, SignalR, basically everything that runs in a browser or needs HTTP or HTTPS. I try to blog about those things, I try to tweet about those things, so feel free to follow me. Now, as a co-founder of a highly successful startup, I already have my Aston Martin. But if you would like your own one, and for the 2 guys who didn't yet activate their MSDN benefits, please do it now, deploy something. I will give you a Hello World solution which you can deploy to make it even easier. That's Aston Martin, or scan the QR code. So the agenda for today. Basically, who knows NuGet? Okay, most of you. Who knows MyGet? Who's using MyGet? All right, come collect a sticker afterwards. I'll give you a brief introduction about what NuGet is and what the problem is we're trying to solve with MyGet and how the workloads are structured. So you get an idea of what our users are doing, how they are consuming our service, and so on. Next, we'll go into how we started. Basically, we started as a blog post and then grew to a product. We're on our 2nd iteration of the architecture currently, and basically refactoring again for a 3rd time, so maybe next year I'll have even more agenda topics. I'll talk about our multi-tenancy, how we handle that. I'll talk about Azure Access Control, not in much detail, but just how we are using those things. We've also had some tough times, or as I like to call them, learning moments, because tough times are typically the things you don't really expect, but you have to react to quickly, and you can learn about those. And I don't know if anyone is trying to start a startup or trying to bring a service online or something like that. I'll quickly cover some of the things you can do with popular tools out there, like measuring which features are being used and so on. So NuGet and MyGet. NuGet is a brilliant thing Microsoft came up with, I think, almost 2 years or 2.5 years ago. It's a package manager. So whenever you needed a third-party solution like an open source project or anything else in the past, you would Google, you would find the DLL, you would download it. Maybe it was compiled for .NET 1.1 and you couldn't really add it to your current project. Maybe you had to find another download. Maybe you had to find dependencies. Maybe you had to edit your web config and add some parameters there. Basically, installing things like Elma, for example, before NuGet was a big pain in the behind. You really had to find the right download, extract everything, make sure Windows unblocked the files and things like that. With NuGet, you just get this small dialog in your Visual Studio. or you have a command line tool as well, where you can just search for whatever package you need, either by name, like this one. I want to install Elma in my project, for example. Or you may want to search for things like, I don't know, maybe I'm searching for jQuery plugins, so jQuery carousel, for example. You can search for that, and NuGet will bring back packages that may match that search results. Click install, it downloads the binaries, it installs them into your project. If there's webconfig or appconfig changes that have to happen, it will do that. If Elma has dependencies, and it actually has some dependencies, it will bring in those packages as well, do the install again. If you want to update Elma later, you can just click update and it will all come pretty easy. Now there's one problem with NuGet. Some on Twitter say there's several problems, but I think there's one problem, which is this one. NuGet is NuGet.org, and every package you publish on NuGet.org is public. So if you're having your in-house framework and you're trying to create packages for several components you're reusing across projects, you probably don't want to put them on NuGet.org, unless, of course, you want everyone in the world to use them. But typically, if it's an internal framework, your competitive advantage, for example, you may want to keep it internal. And that's why we thought of building MyGet. MyGet is a software as a service solution where you can just go, you click Get Started for free, you give your feed a name, and you have a NuGet feed, which you can add to your Visual Studio. You can publish your own packages to it. You can consume packages from it. You can query packages from NuGet.org and add them to your MyGet feed. You can mirror packages. Basically, a lot of additional management tools on top of NuGet. You can store your packages. If you have a private feed, you get authentication and so on. So you can just store your private packages on MyGet. You can create packages. I don't know if you've tried creating a package, but sometimes, depending on the project, it can be hard. Well, we have build services, which is basically just hooking up GitHub, clicking build, and we will try and create the packages in the best way possible. Works for most packages. If it doesn't, just email us. We have security, so you can give people read-only access. Some people may publish packages to the feeds. Some may only consume packages from the feed, so you can do that as well. There's also a symbol server, so if you push packages and you also push the debugger symbols to MyGet, what you will get is Visual Studio will allow you to debug into the assemblies. By downloading the symbols from the symbol server, it will give you full debugger access to whatever library you are installing through that. Analytics and so on. By the way, if you're interested, email cloudburst@myget.org and we'll try to hook you up with a free starter plan for a while. I'm not the only one building this. Xavier de Koster and Yves Goeleve are building this as well, and we are on Twitter as MyGet team. So enough with the sales pitch. Let's just dive into how this thing started and how we grew our product. This is the real begin, May 2011. I wrote a blog post on using dynamic WCF service routes. Bit of a crazy title, but the idea was ASP.NET routing was hot back then, and WCF, well, you can host WCF inside ASP.NET projects. So I was thinking, okay, what if I can build a WCF service and use routing to give it certain parameters and maybe different URLs, but just use routing to point everything to the same service and based on the parameters, decide what to do with it. So that was the initial blog post we did there. Then NuPack came. NuPack is the old name for NuGet. During the release candidate and the beta versions of NuGet, it was actually called NuPack. And they started using feeds where the packages were published, and they were exposed as OData feeds, which was interesting because I just did this blog post, and then there's this OData feeds, and I was thinking, okay, NuGet is hip, and if you're blogging or you're speaking, the thing you want to do is attract people to come see you or read your blog. And the thing how to do that is make use of the typical buzzwords. So just like we're all talking about Windows Azure now, I was thinking, well, NuPack is hip. I just did this blog post on routing, so let's try to combine that thing. And that's what I did. I tried putting that WCF service routing on top of this OData feeds for NuPack back then. And, well, basically came up with the idea of having multiple feeds hosted by just one WCF OData service. And I started chatting with Xavier, and during Tech Days Belgium 2011, we quickly drafted a prototype, which was this one, creating your own private NuGet feeds, MyGet. Another blog post, and basically what we did back then was just create a quick website, add our service routing to that, expose a feed, and you could just favorite packages. You could just say, I typically use these 5 packages from NuGet, and that was your feed. But we had the combination of that. What did we use back then? Well, again, Windows Azure was just around the corner back then. So we decided, well, let's go for Windows Azure. There's MSDN benefits. There's all kinds of ways to getting Azure for free. So why not try Azure and see if we can build something on top of that. We also decided to use Windows Azure Table Storage and Blob Storage exclusively. Not SQL Azure or Windows Azure SQL Database, as it's called today. We decided to go with table storage. Why did we decide that? Well, it's very inexpensive, that's one thing. And again, we were thinking NoSQL is hip and table storage is NoSQL, so let's do NoSQL, right? The best technology choice ever made. We're doing NoSQL. Just because it was hip. What?
Paying the cool tax.
Yeah, the cool tax. But anyway, you'll see later on that that actually was a good decision, even though the reason why we chose it wasn't probably the best reason back then. We also decided to go with Windows Azure Access Control Service because who has never written a user registration or login system ever? You are one lucky guy. It's everyone has done that at least one time and probably even multiple times, and we were like, okay, not gonna do this, let's go with ACS. Everyone has a Microsoft account, everyone has a Google account or a Facebook account, and let's just use that and let people log into the website using that one. So we did that. ASP.NET MVC2 back then, and the Managed Extensibility Framework to tie everything together. Some code from back then, which is pretty interesting. I went through our entire commit history. You see our controllers, and this is the one listing, well, private feed packages. You see that we were just accessing every feed table directly from the controller. No repositories, no whatever in between, just direct access on storage. We were also making use of queries all over the place. No service methods, nothing specialized. Whenever we needed feeds that were visible, we would just query it using link. Good idea, right, for a small project? Or this one, that's also a nice one. Nothing can go wrong if you add a package to a table, right? No error handling, no retries, just catch the exception and so on. Good thing was, we noticed when refactoring the solution afterwards, we put that comment everywhere, so it was easy to find the usages of this perfect exception handling block and replace it with something decent later on. Best practices, well, not really. So our architecture back then was very simple. We still didn't think this would evolve into a project or a product. We were just building this thing as a blog post and trying to create the website, create the application, and we were hosting everything on one cloud service. Why? Because back then MSDN only had one cloud service you could use. We're cheapskates, right? Storage, we were using one storage account where everything was put into, so all the packages, all the feeds, all the user data, and so on. And we were using Windows Azure Access Control. What we did not know, however, was the fact that users would come. We went from like 5 feeds from people reading that blog post, so that's how popular my blog is, to like 70 feeds in a few weeks. And that kept growing. So on average back then we had 10 feeds being added, adding favorite packages to their NuGet feeds. We received emails from people asking for specific features and so on. And we even had data coming in. So what we didn't expect, we built this application with the idea in mind that people would create favorite feeds where 5 or 10 packages were added. And then we suddenly added the functionality where you could actually upload your own packages to that feed. And then the guys from .spatial, which is an open source project for geospatial things, they started pushing their nightlies to MyGet. And that was like 1,300 packages worth 1 gigabyte of data every week they were pushing. So we were like, and not only they, well, a lot of feeds started emerging where people were just pushing nightlies, and well, some guys were even basically copying NuGet.org, so they had like 10,000 packages and so on. So we were, yeah, concerned, let's say it that way. So we started refactoring. We did a lot of refactoring. All the direct data access we had, accessing storage directly from our controllers, we moved that to repositories. These repositories were bundled in services. We had some business logic in there. These services were used by controllers, and basically your typical enterprise application, right? So we were using all the best practices that we have been using in our consultancy work and in other projects. We were doing everything solid, dry, basically all the things you would expect from a regular project. We were implementing that and doing that. On the infrastructure level, we went to 2 instances. Why? Well, we decided if people are using it in this way, and we don't have a real product, but we also don't have any legal disclaimers on the website, let's go for 2 instances so the SLA of Azure kicks in, and at least our service will be up and running at that level. Maybe in our code not, but at least on the Windows Azure level, it would be running, so availability reasons. And we became a startup. Actually, Yves, one of the guys who is building this, had the idea, like, guys, you're growing, why are you not monetizing this thing? So we thought about doing that, and we started evolving into a real product. We started thinking about a business model. We started thinking about how are we going to monetize what people put on this thing. And we did that, and we saw our volume of feeds and packages going up. We also saw on Google Analytics that people were using our website from the European Union and from the US. So we had like a global service running. So we were thinking, okay, this Azure thing is pretty cool. You can have data centers in the US, you can have data centers in Europe. Why not deploy on both locations? So that's what we did, our first architecture. Code level, your typical enterprise application, you have a web layer, services layer, repositories, some core stuff, some data stuff, accessing storage. Storage contained everything, feeds, packages, everything we wanted to store there. Awesome, best practices. Everyone has been taught to build their applications like this, right? Typical business application architecture. But are those best practices? Are layers the good way to build your application? I'm not saying you shouldn't go with layers, but from the spaghetti code we had earlier, where we're just accessing storage directly, we went into lasagna code, where every feature that we would build would have to go into 5 or 6 layers. So that was kind of slowing us down. And you know, there's this periods when building a product where feature requests come in faster than you can hit F5 in your browser, for example. So yeah, it was difficult to get things done. So that lasagna code actually worked a little bit against us. So it was not flexible. At the infrastructure level, we had this thing. So we had, and we still have, by the way, everything in the EU West data center, which is Amsterdam, I think. And then one deployment in North Central US. Why? Because we had users coming from both continents, and we were thinking, let's give them the optimal experience and faster latency and so on. So that's what we did. We put a deployment up in US, one in Europe. Everything was in Europe for data. So all the data was in Europe, packages, feeds, and so on. And we had one web role in every data center. So one in Europe, one in the US. Why one on every location? Well, there's this other service, which is called Windows Azure Traffic Manager, which does DNS load balancing for you. So basically, you can say that every user that comes from the US will be routed to the US data center. Every user coming from Europe will be routed to the European data center. And that's what Traffic Manager does. It does this very well. And we were thinking, okay, we may not get a full SLA, but if one data center goes down or one location goes down, Traffic Manager will solve this for us. We'll just fix it at the DNS level. Maybe it will take a couple of seconds before users will be redirected to the other data center, but that was our setup. In terms of latency, we also decided to mirror all the packages we had in storage on the Windows Azure CDN. So whenever someone would consume a package from their feeds, they would pull it from the CDN and download it from a location close to them. Sounds good, right? I mean, solid architecture. Awesome. Data centers nearby our users, storage all centralized, so pretty easy to manage. Everything in Europe at the data level. We were using the CDN for faster throughputs, lower latency, and so on. And we had DNS failover in case the data centers went down on one of both locations. Awesome. But were those data centers nearby our users? You actually don't know. If there's a network in the US which has better connectivity with Europe, yeah, they will probably be routed to Europe anyway. So depending on the network latency, they will be routed to one data center or not, but not based on the actual physical location of where people are consuming the service. We also had centralized storage, which was a big pain again because of speed of light. You think light is fast and data travels across the Atlantic pretty fast through fiber optics. Not really. You get additional latency, you get additional download times to get data from the data center. So basically, I know there was one feed back then which had like 200 packages on the feed, and to just view a list of all the packages on our website from the US server, querying data from Europe, that page would load like 6 or 12 seconds depending on the time of the day. So that was not very ideal. The CDN back then, we weren't really a fan of that because it gave us more trouble than solution. There were synchronization issues. Sometimes a blob would be available, sometimes it would not be available. There was some downtime and so on, but again, this was a while ago. This was still in preview, so yeah, probably not the best solution anyway. This DNS failover thing, while a brilliant idea, it doesn't really work. Reason for that is that not every ISP across the globe, and especially some from Belgium, seem to follow DNS standards. So time to live, not every ISP respects it as it should be respected. So basically, whenever we had a failure in one of the data centers, it could be that that data center was, or that our website wasn't available for users, typically consuming from that data center for half a day because of DNS update issues. But we persisted. We were still believing in our architecture and still believing that we could do it and solve these problems. So we added caching in the US. So data in Europe, caching in the US, and we would just cache feeds and packages and things like that. Awesome. We also went from 2 instances in Europe and 3 in the USA. I don't know why we had 3 in the USA back then, but anyway, it probably made sense back then. So we were also locally redundant. We had the load balancer in the data center, and if one of the machines would go down in any of the data centers, the website would still be available. But still, synchronizing data from our storage to the cache was slow. It was proving slow. If a user was really bulk editing packages, like deleting a couple of packages, it would take 2 or 3 minutes before data actually flowed back to the US. So bad design, bad choice of architecture, I don't know. The CDN kept having issues, so we decided to drop that one. And of all the instances we had, we basically counted for the CPU percentage of the actual load on those machines. We actually were consuming only 60% of about one machine, while we had a couple of machines. So not very cost effective, right? We were also growing. So we had, our business model was a freemium model where you can just start for free and you can upgrade if you want private feeds, if you want more storage and so on. So we had those subscriptions, but we were thinking, okay, let's try something else and let's also try to focus on enterprise customers, where people can just get their own domain name, deploy MyGet there, and basically have their own private MyGet instance. But that resulted in an architectural nightmare again. It became very complex to separate our public tenants, so the public website where we have the subscription plan model, and the sites for all those tenants. Updating was a pain, caching was still complex, synchronizing caches was still complex. So we decided, okay, maybe it's time to revisit everything that we currently have. So we evolved into our next architecture. We took a look at our workloads, and we were basically identifying 3 workloads that we had on the website. One was all the management. So going to the website, creating a feed, adding packages, configuring security, all those things. Doesn't really matter for latency. Not everyone is daily going to visit our website and change security policies, right? People are probably doing that once a week, maybe once a day, but still, it doesn't really matter if a page loads of a number of packages would take 1 second versus 2 seconds, okay? That's not the best performance, but it doesn't really matter in our workload. What the big workload was, and still is downloading packages. Instead of managing packages, okay, that happens, but typically packages are being consumed from build servers, from Visual Studio by new developers on a team. Basically, anyone doing a build and having package restore in NuGet enabled would download packages from NuGet and make use of that thing. So we thought, okay, that's a pretty important one with regards to latency and download speeds and so on. And then our builds was our third workload, so changing source code into binaries and then into NuGet packages. Nobody cares where that happens. If we did it on a server under our desk, nobody would care because it would just you would just be interested in the results of the compilation and the actual package being published to MyGet. So based on those workloads, we started thinking about our infrastructure. So we still have everything in Europe West. We have Windows Azure ACS there. We have the load balancer, 2 web roles, and 1 storage account, which only contains tenants and queues. Tenants, that's a table basically listing all of our enterprise customers, their domain name, and where their storage account lives, and the credentials to that storage account. We also have our queues in there, so basically everything that you do in our UI gets posted onto a queue, and then in the backend we process that queue and process the commands from that queue. The next thing we do is, well, we still have Traffic Manager there, but as you can see, we have no deployments in Europe North and other data centers. Although, if we go to our portal, you will see that we actually have multiple cloud services in all those regions. Why did we do that? Well, we just wanted to make sure that if disaster really struck on our Europe West data center, we could quickly deploy into one of the other data centers. And having all the DNS and things like that configured up front makes sense if you want to plan into disaster recovery there. Okay, so back to our storage. Every tenant we have, including our public website, that's just another tenant, sits in a tenant table and points to a storage account per tenant. So every customer gets a separate storage account. Our public storage account is separated from enterprise customers and so on. And that storage account per tenant only contains the feeds for that tenant, the packages for that tenant, the user for that tenant, and so on. We also have some storage accounts in the US. We have some US-based customers. And again, downloading packages is the most important workload we have on our website. So we thought, well, let the tenant decide where they put the storage. The fact that our backend is a little bit slower in communicating with that storage accounts over the Atlantic doesn't really matter. We just want to make sure that people in a US company are downloading their packages faster than they would from Europe, for example. We also have storage in Europe North, where we put our backups. Why are you making backups? Right? Some people might ask, why are you making backups? You have 3 copies of storage in that one data center, and as some sources say, you also have 3 copies in the other data center. That's all fine and well, but if I, on a Monday morning or Friday evening, go into our storage account and oops, I deleted the tenants table, that's a massive problem here. So we want to be able to pull that back from a backup. So we do backups in Europe North. Why Europe North? Well, if there's a real trouble in Europe West, we would be able to restore from Europe North again in one of the other data centers. Builds, we put those in Europe West as well, but it doesn't really matter where we put them because they just fetch something from the queue, a workload, a job. They do that job, they compile, they push the package, and that's basically it. So that doesn't really matter where we do that. In codes, we simplified a little bit, so we removed some of the layers from our lasagna. We still have a web layer, we still have a core layer, and we still have repositories and services and so on, but no longer separated across different projects, and we did some massive simplifying of our logic in there. And that core thingy would just access our storage accounts containing tenants and the queues and so on, and also the storage accounts per tenant. I'll come back to the multi-tenancy later on because the entire web application basically doesn't know about tenants. It's our DI container sitting in the MyGet core which knows what the domain name is that we're accessing and will pull back the correct storage account. So in our programming model, we actually do not have to think about our multi-tenancy, which is interesting. Our first architecture was scaled across the globe, but had synchronization issues, had caching issues, and so on. We were prone to all issues you could have with synchronization and latency. So it could be that you deleted a package, but that the cache was updated pretty fast, and if you deleted another package, that the cache would not be updated with that first delete. So we had some problems there. And we thought, how are we going to solve this? And we read a bit about event-driven architectures, and we're thinking, okay, event-driven architecture, CQRS and things like that, that's a pretty massive undertaking if you have a big code base to convert to that model. It's also a big mind switch you have to make. So we decided to borrow some concepts from an event-driven architecture and build our solution on top of that. So currently, I think we're about 90% event-driven, but we're still working on getting that to 100%, but it's a big undertaking to do. Are we a full event-driven architecture like the textbook example of an event-driven architecture? No, we just borrowed some concepts and we are still learning about the way we actually have to do this in the most optimal way. But in MyGet, we have some actions that put commands on a queue. So every command implements an iCommand interface and we put that thing on a storage queue. Then we have our backend and that one processes those commands. And when some command is processed, we sometimes, well, mostly we throw an event on that queue again. So for example, if you delete a package, that's a delete package command. Once that's done, we throw a deleted package event on that queue as well. So if anyone is interested in the fact that a package just got removed, we can hook into that event as well. Every handler, so we have some code in there which listens for commands and handlers. We can have multiple handlers and handlers can subscribe to those commands and or events. I'll give you some examples in a moment. One thing that is important though is that those handlers have to be idempotent, not depending on others and not depending on states. So whenever a handler executes, for example, a delete of a package and something goes wrong, if you know storage queues, you know that if you do not delete the message from the queue, it will reappear again. So if the package got deleted, but later on we failed during that task and we had an exception and the message was re-queued, the next time we process that message, we should know that the package has already been deleted and maybe just discard the message. Or do it again, but not depend on the previous state because the previous state is faulty because it was already halfway processed. An example of a login, well, we basically have one ground rule as well, even because, yeah, we were refactoring from this first architecture to the second architecture, and doing that we identified a lot of possible commands and a lot of possible events and a lot of possible handlers. So we had this idea, okay, if we want to tackle our event-driven architecture and our synchronization problems, probably the best way to go about that is to only do this where it makes sense. If we have a longer running operation or something that is pretty resource intensive, we may want to put it on the queue. If it's just one operation, we can immediately do it. So for example, a user login is one of those things. We do not use a command for that. If you log in and we want to store when your last login was, for example, we just read the profile, update the date, and write it again. No command there, no backend processing, that just happens inside of the website. What we do after logging in is throw a user logged in event on the queue. So maybe there's someone interested in the fact that someone just logged in. Well, we can have a handler subscribing to that event and processing something based on that one. A more difficult one is changing the feed owner. I create a feed for my company. I work at that company for a while and I decide to leave. And that feed has to be transferred to another owner. That's changing the feed owner. That's many operations. That is reading both user profiles, which can go wrong. That is reading the current access rights and updating those current access rights. And pushing those new privileges to symbol source. So for the symbols, we are actually using a third-party service hosting those symbols. Those guys know what they're doing, so we trust them in doing that. But if you change the feed owner on MyGet, we also have to change the feed owner on symbol source. So that's a lot of commands for just changing that feed owner. Well, what we do is, if you decide to do this, you actually queue a change feed owner command on our backend. That thing gets handled by a handler. And after that has been processed, we throw a feed owner changed event on that queue. And then maybe someone else can subscribe to that one, and we can have an entire chain of events happening. So what happens when you change the feed owner? This is simplified. There's much more action going on in the back. But what happens is the UI puts a change feed owner command on our queue. We have a handler, which is the change feed owner command handler, listening to this specific event, does its job, maybe reads the privileges, updates the privileges, and so on. And when it's finished, it throws a feed owner changed event. And then we have another handler, which is the symbol source handler, which listens for that type of events. For example, if the feed owner changed, that handler will update symbol source, making sure that also there the feed owner gets changed. We also have an activity log. So if you log into the website, you can see whatever has happened on your feed. Well, the fact that the feed owner changed is something you want to reflect there. What we don't do is in that change feed owner event, write an entry in an event log somewhere. No, we just do that, throw an event, and have a second handler listening to that event and logging that activity for us. So we can have one event with multiple subscribers doing an action based on that event. After symbol source updates, we throw a symbol source event, and maybe there's someone else interested in that, and they can do an action based on that. Don't get me wrong, this is not a workflow. You don't want to code your application that whenever a change feed owner event happens, you expect the symbol source event to come out eventually. No, you just want to handle that one event, throw another event, and maybe based on that some other things may occur. But you do not want to write your own workflow based on this, because you would quickly have a lot of handlers and a lot of trouble orchestrating this entire thing. What's the gain of using this event-driven architecture and no longer doing everything inside our website? Well, we are now running on 2 instances, and that's mostly for redundancy. So in the EU West, we only have 2 instances running for, I think it's about 30,000 visits a day currently, including downloads and actions and so on. And that's basically just for redundancy. I think CPU usage, last time I checked, was 20% on average on both machines. So 2 small instances, by the way. It's very flexible. For example, implementing this activity log feature was something that was really easy. We had all these events saying, I just updated a feed, I just added a package, I just updated the version, I just listed or unlisted a package. We would just subscribe to those events in an activity log handler and put it in one table which builds the activity log. That feature literally was written in 3 hours, including the UI and so on. So that's really easy to do. So instead of having this lasagna, where it was really difficult to implement new features like this activity log, for example, we would just subscribe to the events and do everything there. If you would want to do that in this lasagna model, you would probably have hooks everywhere, like whenever something changed, you want to call into another service and so on. Not anymore, we just throw the event and consume the event and do something based on it. Okay, storage. Since we are on our second architecture and our first thought of using storage was using table storage because it's cool and NoSQL, we didn't change for a relational database. Good question may be, why didn't you change for a relational database? It's much easier to search on, it's much easier to build a relational model and so on. Well, first of all, we had our data, and the data migration would be difficult to do probably. But using this event-driven architecture, you actually don't have to really think in a relational model anymore. Because, for example, our packages are stored, I think, 3 times currently, based on how we want to query them. But if you add a package, we have this package added event, we can have a couple of handlers updating the specific view for that specific use case, and we can just show it in our UI. So we don't really have to think about building a relational database, or we don't really have to think about how are we going to store this in table storage. We adjust storage for the use case in the UI. And based on that, we can have 1 or 2 or 3 or 4 handlers updating that specific view for that specific use case in the UI. Now, another thing is you learn a lot about how Windows Azure Storage and especially table storage works. And I don't know, is anyone building completely on top of table storage or mostly? Good, a couple of guys. It's actually ridiculously cheap to build on top, and it's ridiculously performant if you know what you're doing. And the one important thing to know what you're doing there is partition key and row key. Those are both the unique identifiers of every entity in table storage, but they are also the performance factors. If you create a partition key and you put millions of objects in one partition, it becomes more difficult to query them. Why? Because if you want to query that entire partition, you will have to download multiple pages of that one partition. But still, that's pretty okay. It becomes more complicated if you have, for example, data where you want to store 5 entities in that partition key, 5 entities in that partition key, some more in that partition key, and you want to query over multiple partitions. Inside Windows Azure Table Storage, those partitions may be located on different servers, and that means additional latency for querying. So if you want to store your data, you have to think about the partition keys and optimize for fast querying. And for example, storing packages is an interesting one. Packages have a unique identifier. They have a version number, and they have all the additional data. But in our model, we have multiple feeds, so we also have the feed identifier. So how do you store 3 identifiers? There's no secondary indexes or anything on table storage. Well, we decided to just go with 1 table for every feed. So we have a quick way of querying 1 feed because it's all in 1 table. Then our package ID is the partition key, because typically if you want to download jQuery, for example, you would fetch all the versions of jQuery and take the latest version of that and serve that one. But that's pretty efficient. If you want to fetch by ID, you can quickly do that because it's in 1 partition. You don't have to wait all the latency of having the partition spread across multiple servers. And then we use the row key basically just for ordering based on the version number. The first one is the latest version, so we serve the latest version there. There were some other issues we had with storage and that we had to tackle. One was reading 1,000 rows becomes slower, and reading 2,000 becomes even more slower. Why is that? Because, well, Windows Azure Table Storage is also an OData feed and is paged per 1,000 entities. So every time you do an HTTP request to fetch a data set, you have to do multiple if that data set contains more than 1 page of results. So if you want to get 10,000 rows out of table storage, that would mean 10 HTTP requests, 10 times latency, 10 times, well, you know. So for the bigger feeds on MyGet, we had a problem there that reading a lot of rows was still kind of slow. And we decided to go for a caching solution there. Now, nowadays, and we're actually looking into that, you have all these in-memory tables, in-memory caches and so on, shared cache, distributed cache, whatever. But back then, that was all still in preview, and we actually had a product, so we wanted to do something stable. And we are actually caching feeds on blob storage. That's still an HTTP request, but serializing 1,000 or even 10,000 rows in JSON and zipping them on blob storage is pretty small, pretty fast to download from blob storage, and really fast to query because 10,000 entities in memory is still not that much, and you can easily query over them in memory. So that's what we're doing there. Fun fact, I think we currently have some 30 or 40 gigabytes of storage with regards to packages. I think there's about 1 gigabyte of metadata, so all the package versions and properties and so on. In our cache, because of the small JSON format, because of the fact that we zip all this data, we basically have our entire public tenant, all the metadata sits in like 10 megabytes of blob storage. So that's a really fast cache. It's pretty efficient, and it's really, 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 really inexpensive compared with all the other options that are out there. But we may change this one. How do we update the cache? Well, we have this event-driven architecture. So whenever a package is added, there's a package added event being thrown. We have a handler listening for that event, and that one will update the cache. Okay, multi-tenancy. How to bring multi-tenancy into code? That was an interesting question. We decided on building multiple tenants, so all the enterprise customers later on. So we didn't think about that up front. And we were looking at our code base and we were thinking, okay, multi-tenancy is hard to introduce in a code base if you do not think about it up front. So we decided, okay, a tenant is actually nothing more than a context. If you're having an HTTP request, you have a request context containing all the data about that request. Well, tenant is just another variable on that request context. So every request coming in will have a different request context, but also maybe a different tenant context. And that's what we did. We decided to move a tenant into something that could be handled by our dependency injection container. And basically, all the website knows is a storage account, and that storage account is populated by our dependency injection container. So here's what we do. We have an iTenant context interface. We register it per request. So every time a new request comes in, we create a new tenant context and resolve the storage account and so on. And then the actual implementation of that thing will just, based on the host name, select the right storage account from this tenant database and give that back to the code. And all our code knows is a storage account, but the DI container makes sure it's the right storage account for that tenant. And that's actually a pretty way of doing things, because all the rest of our code doesn't really have to care about the tenant. It only cares about storage and packages and feeds, and not so much the tenant. So that's how we do this one. Azure Access Control, another nice one. You quickly have multiple applications. If you start building your application, well, we have our public website, we have a staging one, we have our local developments, we maybe have some customers on different domain names, so you quickly have a lot of applications with different requirements with regards to authentication. Maybe the public website will bring you all of the identity providers, so Microsoft account, Google, and so on. Maybe one enterprise tenant wants to bring his own ADFS and not make use of Microsoft account or Google. And maybe your development environment, you only want one because you always use just one for development. So that becomes quickly something like this, a real spaghetti. A lot of loose ends you have to couple to each other. So ACS is brilliant in solving that problem. So we have ACS, and in ACS we have configured all these identity providers. So we configure Microsoft account, Google, Facebook, GitHub, whatever we have. Those are all configured in there. On the other side, we configure our applications. So we say that domain name is that site, that domain name is that site, that domain name is that site, and all those different applications are listed in ACS. And inside ACS, you can actually connect the dots. So in ACS, we configure that MyGet.org uses all of the identity providers. That maybe customer one only uses the ADFS from the right side. If some customer wants to use and ADFS and Facebook, that's just a checkbox in ACS. If you want to build this inside your own code, well, good luck. I think it's a massive undertaking to do it correctly, and ACS is brilliant in solving this. And what's even better, as a developer, you only have to trust one identity provider, which is ACS. And you know that you can trust ACS because that's the one you configure. It's the one with the certificate you trust. So you can just trust one in your application, build for one, and based on how you configure it, users may come in, from any identity provider there. ACS for MyGet, well, we started with the idea we would not need user registration. We only have one trust relationship, as I just explained. You only have one identity provider to trust. We can have Microsoft account, Yahoo, Google, Facebook, whatever. We also built some of our own. So we built one for GitHub, we built one for Stack Exchange. I think Twitter is in there as well. And why is that? Because users were asking. Some users wanted one account for their development purposes, which was their GitHub account. So we decided to build a GitHub identity provider there. And then we were thinking, okay, we're polluting our code base with identity providers. Let's pull them out, and that's what we are currently doing. We are pulling them into socialsts.com. You can just go there, add your GitHub OAuth credentials, and we'll do the mapping to register it into your ACS. So we're trying to pull those out as well. So if you're interested, by the way, that's still alpha code. So if you're using it, please email me if there's an issue, and I will try to fix it. But we're working on getting that thing live for production and basically pulling all those identity providers out of our own code. One small trick we do, because of the different domain names we have, is this one. If you look at Windows Identity Foundation, at the configuration of that, you will have to configure your audience URIs. Basically, you have to tell the framework that you trust logins for a given domain name. Now, since all the domain names we have for our website may vary based on the tenant table we have, we don't really want to configure those in our web config. So what we do is we fetch the configuration at runtime, and we just add all domain names for our tenants to those audience URIs. So whenever someone logs in on any of the domain names we have, they can just log in. So if you need something like this, you can just access the configuration programmatically as well and configure your identity foundation like that. All right, some tough times. I see I have 10 minutes left, something like that. Tough times or learning moments. Well, like any online service, big or small, every online service will suffer some downtimes or some issues, and that's the moment you can learn. This was an interesting one. The first huge downtime we had July last year. We had some symptoms. Users were complaining about downtime, but we had SMS monitoring, and we didn't receive any text messages, nothing. No emails. We went to the Windows Azure Management Dashboard. Everything was up and running. But still, people were complaining about downtime. And we went to the website and it worked, although a bit slow, but we were on a mobile connection because typically when something like that happens, you're not at a laptop and not at a good connection. So we're thinking, okay, it's just our mobile connection which is being slow, but we're still up. And then at a given time, we start getting text messages and emails saying site up, site down, site up, site down. So our SMS credits went real fast there. And that's what you see in this graph. So you see a lot of up and downs in that period. But yeah, what's the cause? Everything was up and running if we went to the portal. If we looked at the event log, everything looked fine. What could it be? At that time, we had just deployed our multi-tenant architecture, and we were thinking, well, maybe it's because of that one. We also just enabled storage analytics, and we were thinking, okay, that's a new feature on Azure. Maybe storage analytics is actually triggering throttling on our storage account. Maybe that's the case. We also saw that Elma was actually giving us exceptions, stating that there were throttling issues on storage. So we were like, what's this? Another thing we saw in our events queue was that there were, I think, 16,000 unprocessed messages. So we were like, let's dive into that. So we started looking into our website, trying to reproduce this problem, trying to figure out what's going on. And we found that one single line of code actually took down our entire application, a get hash code. It turns out that Entity Framework, or the Entity Framework version that is being used to store your OData objects in table storage, for example, is making use of get hash code to determine if it's already tracking a specific object or not. And in this case, we had two objects, different packages, but still they were yielding the same hash code. And because of that, Entity Framework was throwing an exception saying, sorry, I'm already tracking that one and you have different data here, I'm not going to track it twice. So you may be thinking, are you saying that you crashed because of an exception? Well, yes and no. We had exception handling there. We were actually handling exceptions pretty well. And we were retrying exceptions. So whenever an exception occurred, we would retry the operation because, well, something can happen and maybe you just want to retry the exception, the operation. So the fact that we retried this exception meant that messages kept being in queue and kept being requeued and threw an exception again and again and again and again and again. So we were basically being blasted by exceptions and retries. The fact that these retries were happening also meant that the load on storage was increasing, and because people were hammering the website with F5s because something was broken, right? You do that when something is broken. They were also queuing storage, fetching tenant details, fetching feeds, fetching packages. Because on the back end, everything was throttling, and the front end reads from the same storage account, that's even more storage transactions, so more throttling. So we're basically destroying ourselves and just going down because of that. And it was really starving IIS worker threads and basically blowing out IIS and so on. So lessons learned, don't write your own Get hash codes. That's one thing. But also that one simple bug can actually affect an entire application. So if you're building applications on Windows Azure, I would strongly suggest to try and split out some of the work and partition your workload so that whenever something goes wrong, maybe that something will crash, but not the entire website. Our monitoring wasn't really optimal, and we've been working on that one, and that's pretty good now. And yes, that get hash code was still from when MyGet was a blog post, so that was something we missed during those 2 refactorings, and yeah, bad thing. Another thing, a huge downtime last year. I don't know if you had something running on Azure in February last year, or this year, sorry. Everything went down. Why? Because storage was using an SSL certificate. That one expired. The storage SDK would no longer connect to your storage account because the certificate was expired, and yeah, everything was going down, including the management portal, because that one apparently was also using that same, well, a storage account using SSL and also going down or taken offline or whatever. So we're seeing furious tweets about Windows Azure, and we could basically do nothing, not even go into the management portal and check what was wrong. The cause, well, this global outage of Windows Azure. Now, what did we learn about that one? Well, that clouds can fail, that's for sure. And we were thinking, how can we solve this? One of the approaches we thought of was moving from HTTPS to HTTP to, whenever this happened again, mitigate that risk of expired SSL certificates. But that would also mean that for those tenants we have in the US, we would send unencrypted data over the internet. So not the best solution. Also, what I think is this happens once, but I'm not sure this will happen twice because of an SSL cert. Maybe something else, but not because of this one. We also learned that Windows Azure being down impacts us quite a bit. So how can we solve that? Well, maybe fail over to another cloud or our own infrastructure, but we decided against it for now. Because that's pretty expensive. You have to architect your application again for those different clouds, because we have really Azure-specific code, so we can't just move to Amazon or wherever. So we decided against it. What we are doing now, since I think 2 or 3 weeks ago, is backing up outside of Windows Azure, so in case something really happens and people want to host their own NuGet server, but with the packages that were stored on MyGet, we can actually send that back up and people can keep on working in the worst case scenario. Another one, new features, and we were bitten by this one last week again. If you introduce new features, they may sometimes be quite popular. So we introduced retention policies where you could specify that whenever you upload a package and there's already 10 versions of that package, remove the 11th version. Something like that to keep your feed clean. We introduced that, and people with the large feeds enabled it, and we had 3 million commands in our queue. And people started complaining, Mike, I'm not seeing the new packages I uploaded. Yeah, duh. Well, on our end, because that message was in the queue, and the view would eventually be updated, but the queue was just quite hammered. And it would take a while before that cache would be updated. But the package was accepted, just the view wasn't updated. So we decided to scale out, and we moved to 20 instances, and about 5 minutes later, we had processed those 3 million commands. So that's pretty nice. Another nice thing is we now moved this to towards the auto-scaling feature on Windows Azure. So we use the auto-scaling feature based on our storage queue, and whenever we see there's a large number of commands per instance in that queue, we will auto-scale. So we actually solved this by auto-scaling. Another thing we are going to do is use feature toggling and roll out features gradually, so not everyone at the same time can enable retention policies, for example. On retention policies, if you look at our blog, sorry for the MyGet users, we were down last week for 4 hours because of a new feature, and again, 1 line of code biting us. But anyway. But overall, it's pretty okay in terms of uptime, both on the Azure side and on our side. One last thing, and I think I will go over time 3 minutes probably. We are constantly being bitten by ourselves. We introduce a new feature, and if you're a technical guy and you are working on a product with passion, what you typically do is think about features and think about cool stuff and, wow, this is cool and awesome. Let's do build services, for example. That's a nice example. That's a massive feature, but we didn't think about monetizing it when we started building it. Which means if we want to monetize build services, we would have to refactor again because we want to have metering in there, billing in there, and so on. So if you're building an online product, I would say do not think feature, but think revenue first and then build a feature after you thought about that one, because we're constantly being bitten by this one, and even still. How can you do that? Well, measuring things. You can also measure whatever is happening in the application. What features should you actually build? How do you know that? Well, telemetry. Put something in your application, monitoring what features people are using on the website, and monitor what might be a good feature to roll out next. And we do that using Google Analytics. You don't have to build your own code. We actually ship the components we built for that using MyGet. So if you install Google Analytics Tracker, you can actually log to Google Analytics from your code. And this is what we see. That's a bit of an old screenshot, but we have our features there. So you can see that the traditional login was quite a popular feature. So we do have usernames and passwords. Why do we have those? Because in Visual Studio, if you consume a private feed, you have to enter credentials. So we can't use Live ID or Google or whatever there. So we had to have some sort of a username and a password. Apparently, people were using that one on our website quite often, logging into the website using that same login and password. And because of that high number of feature uses of just logging in with username and password, we decided to build a user registration page anyway. And people seem to be registering without using their Facebook or GitHub or whatever account. So they really like the fact that they can just register a new username there. And we did some user checks, and people actually don't really like tying their Facebook accounts to their development stuff, for example. So by measuring that, we saw that we needed a traditional user registration page. Another one was this trigger build action. We get a lot of builds on build services, so that's a clear pointer that we should keep building out build services and improve that feature and so on. Also, that's another one, feed discovery. We actually did a blog post making it much easier to add third-party feeds to your Visual Studio and your NuGet configuration. We did a blog post, we did a tweet, we got 2 or 3 retweets and 5 readers on that blog post, and we were like, not too popular, that feature. Our statistics proved us wrong. We saw that in the statistics, this feature was actually being used quite often. So yeah, it's a popular feature after all. Downloading packages as a zip. Well, we thought that would hog our server and people would start mirroring their packages from their feed locally. We actually had 2 or 3 users making use of that thing, and our worry, where we thought this would be a highly requested feature, was wrong because apparently only 2 people were using it in the past few weeks. So that's the data you can get there. So in conclusion, well, we had NuGet, we had MyGet. I gave you a story how we started from a blog post to a full-blown product. Some things we didn't know, some pitfalls we had with regards to storage, with regards to our architecture. We see multi-tenancy. We've had our tough times, and do learn of your tough times. Try to find the root cause, try to blog about it, and try to really analyze what happened so it doesn't happen again. And measure everything that happens. With that, thank you for the session, and I think Scott's up next. Thanks.